Solar cycles. What's really driving climate change? Sol, our Sun. 1.3 million Earths could fit inside our Sun. It also accounts for 99.86% of the total mass of our solar system. Our Sun goes through periods of solar maximum and also solar minimum. Each cycle typically lasts 11 years, but longer spells of minimum and maximum have both been known to happen often and frequently. Here we can see historically the longer periods of minimum and maximum. In the last 3,000 years there have been 2 periods of maximum and 6 periods of minimum. Each of the periods of minimum is approximately 200 years, and amongst them every 400 years there is a larger one. We're currently just coming out of the modern maximum. This diagram is showing a solar maximum, showing that solar winds from the Sun are protecting the Earth from cosmic rays coming in. Solar maximum. When sunspot count is high, a stronger solar magnetic field and solar wind block more cosmic rays from the solar system, and this prevents them from entering the Earth's magnetic sphere and atmosphere. This diagram shows solar minimum, showing that solar winds have decreased in strength, allowing for cosmic rays to bombard the solar system and Earth. During a solar minimum, and particularly in a grand solar minimum, more cosmic rays enter Earth's atmosphere. Here, these high velocity particles, mostly protons, collide with atmospheric atoms and dissipate in a cascading mode into smaller subatomic particles. These particles act as a cloud nuclei by ionization and propagate low-level cloud formation. Some particles may reach the Earth's surface and even penetrate it. In this way, more cosmic rays accelerate storm formation, erratic rainfall, stormfalls, hails, local flooding, and in the long run global cooling. We add to this earthquakes, volcanoes, lightning, and other electric events as an enhanced risk of solar flare that can disrupt our electrical grid. This extract from a recent article shows how volcanic explosions can be attributed to cosmic rays. I've added a link to the bottom of the video, so please take a look for yourself. Volcanoes with silica-rich and highly viscous magma tend to produce highly explosive eruptions that result in disasters in local communities and that strongly affect the global environment. We examined the timing of 11 eruptive events that produced silica-rich magma from 4 volcanoes in Japan over the past 306 years, from AD 1700 to AD 205. 9 of the 11 events occurred during inactive phases of solar magnetic activity, which is well indexed by a group of sunspot number. This strong association between eruption timing and the solar minimum is statistically significant to a confidence level of 96.7%. The effects of cosmic ray influx. Ionization of atmospheric molecules causing cloud nucleation. A cooling effect caused through cloud cover. Increased snow and ice cover, reflecting heat. Flooding and droughts caused through extreme rainfall events, basically cloud dumping a month's rain in one day, leaving huge areas with no rain. Jet stream disturbance due to air temperatures differences at different altitudes. You can currently see that happening now in the Arctic, and the Met Office made quite a good video about it. It's worth looking up on YouTube. Increased UV radiation causing crop damage and wildfires, and also damaging the ozone. Also, coincidentally, during the last solar maximum we've been repairing the ozone, and that's why it's back to good status again. More extreme, and often earthquakes and volcanoes, can also cause extreme cooling to be accelerated due to potential ash cover. Bet they don't have that in their models. More extreme lightning storms due to the atmosphere being charged more. That just makes sense. Cosmic rays have the potential to change our life on Earth. Not only that, they have done not so long ago as 400 years. Why don't we know about this in school? Why isn't it taught? Professor Sarkova mentions in her work that Earth's magnetic fields also act like a barrier for cosmic rays, so I decided to take a look into them too. During the Maunder minimum, Earth's magnetic field was a lot stronger. In the years 1850 to 2000, it dropped in strength 10%, and 2000 to 2010, another 5%. In 1900, the magnetic North Pole was moving a few kilometres per year. Today, it's moving 80 kilometres per year towards Siberia. If we was to enter a grand solar minimum with a lower magnetic field, we would have less protection from cosmic rays than in the Maunder minimum. Bad news then. Professor Sarkova's prediction is the only one really worth showing, as she has a 97% success rate compared to most people, which are nowhere near that. She does predict a Maunder minimum similar event in the next few years, so we'll know soon enough. But if it's not at the end of this cycle, it's going to be at the end of one of them soon. This is a list of historical events that happened during the last Maunder minimum. It's too much for me to list, but I thought it would be an interesting way to end the video, because if it's happened before, it can happen again.
Wow.